Folliculogenesis is the development of the follicle that surrounds the oocyte. The oocyte, as you will recall, if we zoom in on this figure here, remember that the oocyte, prior to birth, the oocyte is going to go through the process of meiosis 1, but it will arrest in prophase 1. I've drawn a circle around what is the nucleus of the oocyte. Recall that the nucleus will break down in prophase, but in this particular diagram it's shown here as having not yet broken down. The plasma membrane of the oocyte is here. And surrounding that plasma membrane is what we call granulosa cells, which can also be called follicular cells. Okay, granulosa / follicular. In the primordial follicle, we really just have a very small layer of those follicular / granulosa cells. And by the way, you're going to hear the term granulosa frequently. We actually talk about granulosa cells in the renal system as well, as being responsible for releasing actually renin. So they tend to be secretory cells. And so we reuse that terminology when discussing cells that have granules in them, which are actually vesicles filled with secretory molecules. The primary follicle begins to develop and will develop prior to birth and will develop so that we have a nice layer of those follicular cells as shown here. The oocyte, again showing here, this is the plasma membrane. And we'll have a very primitive zona pellucida, which is made up of glycoproteins. And you can kind of see it shown as just the shaded in color here. Again, remember that we're still in prophase 2. Prophase 1. So I'm just going to write pro 1 as a reminder there. These follicular cells create the formation of this, well, what we collectively call the follicle, which includes the oocyte and the layer of the follicular cells. Now, importantly, this process is gonadotropin independent. We don't need FSH, we don't need LH. Remember, those are the gonadotropins. We don't need G and RH. These primordial follicles are relatively long-lived. Remember, we're going to have these primary follicles, and the primordial follicles and primary follicles that will live until puberty. Of course, not all of them do. You will recall that many of them will decay prior to puberty, so that we only start out in puberty as having 200,000 to 500,000, 500,000 cells, oocytes, follicles. The a follicle will then, at the beginning of each menstrual cycle, so as the female enters into puberty, the follicle will begin to develop and become what is known as a secondary follicle. Let's take a look at that one. We still have an oocyte nucleus, but at this point we're going to begin to complete the meiosis process. At least meiosis 1, I should say. The oocyte, again showing here's my plasma membrane for my oocyte. The oocyte begins to develop a much more robust zona pellucida. So this is glycoprotein. Okay, a layer of glycoprotein. I believe in a previous video I called it glycolipids, which was incorrect. So I want to make a correction here that these are glycoproteins. Notice the follicular layer begins to get a little bit deeper, a little bit more robust as these follicular cells / granulosa cells begin to proliferate. I also want to point out the development of what is called theca cells. These are the cells shown here. Okay, and these cells are going to surround the developing follicle. They will become part of that follicle, and they are going to essentially contain eventually, once we have ovulation and the conversion of the follicular cells into the corpus luteum, they're going to be part of that structure. The development of the secondary follicle is also gonadotropin independent, and so that's kind of an interesting thing. Another thing that begins to happen, and we actually start to see this kind of early as the secondary follicle begins to develop into what is known as the tertiary follicle, is we begin to create a fluid-filled layer, and we're going to take a closer look at that. But that fluid-filled layer is what is going to be the precursor of something called the antrum, and I'll get to that in a minute. Now, importantly at this stage, the follicular cells, these little guys here, they're going to start secreting estrogen. Not a lot right now. Fairly low levels of estrogen at the moment. But as the number of follicular cells increases, the amount of estrogen being released is going to increase. Now, the estrogen is a family of molecules. It's not just one hormone. It's a family of hormones that are all classified and called estrogens, plural. The estrogen that is released in this process, as I mentioned earlier, is actually estradiol. Okay, so keep that in mind, estradiol. And the more follicle cells we have, the more estradiol that we produce, and it's produced through the conversion of cholesterol into these estrogens. Okay. The next step for folliculogenesis is finally dependent on a gonadotropin, and the gonadotropin it is dependent on is FSH. As we look at what changes FSH induces, we see that the follicle actually enlarges. I'm going to circle my oocyte, and you can see the oocyte right here is quite small. The oocyte did not shrink. Okay, it didn't get smaller. In fact, it's gone through meiosis 1, and it's in meiosis 2, and it's arrested at this point as in mitosis 2. Notice it is surrounded by follicular cells, okay, or granulosa cells. Remember, they're essentially the same thing, okay, in this context. But also look at this. We end up getting this pocket formed, okay, and this pocket is called the antrum, and it is filled with fluid. Okay, it's just filled with this fluid that is going to, whoops, I've got a really big marker right there. That's all right. We're going to work with that. This fluid that is building up pressure within the follicle. Notice also that my layers of follicular cells have increased. Whoa, crazy. Sorry. Let's find a reasonable shape. All right, size. So my follicular layers have increased in depth. And we actually have several layers surrounding that oocyte, protecting that oocyte. But equally important is these follicular cells are now releasing more estrogen into the surrounding environment. Now remember our menstrual cycle, that estrogen or estradiol is moving to the uterus, where it is stimulating the proliferation of the endometrial layer, the endometrium in the uterus. The tertiary follicle will mature into what is called a Graphene follicle. And the Graphene follicle is the final stage. Usually only one of the follicles make it to this stage. Remember this 20 or so are developing, okay? Usually only one will finally make it to the Graphene follicle stage. The Graphene follicle stage it's just filled to bursting with fluid. It's very, very large, and it buds up right against the outer rim of the ovary. And essentially, if we were to zoom in on that ovary and we were to see essentially the outermost part of the ovary, what we would see is this Graphene follicle, quite large, with our little teeny tiny oocyte like so, filled with just this ton of fluid, and I did not intentionally make it look like a puppy. Here's my oocyte. Okay, anyway, ready to pop. Okay, it's ready to pop. It is kind of like a miniature cyst. Okay, it's not really a cyst, but it's kind of like that in that sense that there's a lot of pressure, and if you were to squeeze it, it might just burst open. And that's basically what happens, actually. A surge of LH causes a contraction of the tissue of the cells in the oocyte, in the ovary, and essentially cause this cell to squish and pop and rupture. This is actually an inflammatory response, and it can cause pain. Not every woman will feel that, but there are some that are sensitive to this pain, and they will feel a little twinge around the time that they ovulate, a little twinge of pain. By the way, some conditions actually will cause actual real cysts to form. And when those cysts rupture, it's excruciatingly painful in some of those conditions. Polycystic ovarian disease or syndrome is a disease in which multiple cysts form in the uterus through what is a normal physiological process that essentially goes haywire. And all of those cysts are producing hormones. I didn't mention this, but I should mention this, that in addition to the estradiol, there are other types of estrogens being produced, and even a little bit of testosterone. Our ovaries do produce that. Now, if we move on from the Graphene follicle then, and please make sure you understand that this is LH dependent. So this is also gonadotropin dependent, but the gonadotropin we need is the LH. Okay, without it, we don't get this little contraction that results in the bursting of the Graphene follicle. Now, folliculogenesis also will include the development of the corpus luteum. Now, if we zoom in on this, I want to kind of explain what we've got left over. All right, so I'm going to zoom in here. And we're going to look at my little oocyte, which is right here. And this is the leftover follicle cells that kind of come with it. The zona pellucida, we can't really see it here, but I'll kind of sketch it in. It's going to surround, okay, that oocyte. Okay, that's the glycoprotein layer, all right? And that's essentially what is going to leave and travel down the fallopian tubes towards the uterus. It'll be collected by the fimbriae of the fallopian tubes or the uterine tubes and passed down into the uterus. Look at these tissues here though. Let's kind of highlight these. These are the theca cells. That is not showing up. Maybe green will show up better. Nope. Anyway, all right. Just pretend with me. Maybe we'll do pink. We'll try all of the above. All right. So these are the theca cells, as well as some residual follicular cells that are also all part of that, okay? They're left behind. And it's those tissues that are going to develop into the corpus luteum. You can see this outer layer here. This is created by the theca cells, okay? This kind of boundary that exists here. And the follicular cells are these. But they change, they differentiate, they turn into something different. They still secrete that estrogen. Okay, yes, estrogen is being secreted. But as this matures, we're also going to produce the progesterone that we need to communicate to the uterus and cause the endometrial layer in the uterus to continue to proliferate, but also to become secretory tissue that releases growth factors and other important chemical messages into the surrounding tissue to promote implantation. And as this corpus luteum matures, I mean, it essentially starts from the moment we get this rupture. It begins this maturation process. It enlarges, it matures. The levels of progesterone increase. It will continue to produce progesterone for a little bit, but then it will begin to degenerate and become what is known as the corpus albicans. This is assuming that we do not get implantation, that the fetus, that the oocyte is not fertilized. And because it's not fertilized, we no longer need to make progesterone. We actually need to repeat the menstrual cycle so that we have a chance to perhaps get a fertilized egg the next time, assuming we want to. And back before, of course, any kind of birth control, that essentially, each cycle was a possibility of getting pregnant. Now with birth control, we can actually time things and make pregnancy occur. Not make it. There's no guarantee of pregnancy, but we can prevent the probability of pregnancy until we think it's convenient, until we want children, if we choose to have those children. Now, if the oocyte is fertilized, and it's usually fertilized in the fallopian tubes, then the fertilized oocyte will implant, and in that implantation process, as the placenta, the baby little placenta just beginning to develop, it's going to start releasing a hormone called human chorionic gonadotropin. We'll talk a little bit more about this. I'm going to review the hormones again. But it begins to be secreted, and it actually maintains this corpus luteum so that it continues to produce the progesterone. It does not maintain it forever. Eventually, at some point in the pregnancy, the placenta will be big enough and fully mature, at which point during this process the placenta takes over for the corpus luteum, and the corpus luteum then at that point will decay into the corpus albicans.